Okay, hello, assalamu alaikum. Can you hear me? Hello.
Yes, I can hear you.
Okay. So basically, today is our second number of class, and we already cover our first day. So okay, just I start my recording.
Yeah.
Okay, now can you see my screen?
Yes.
Okay. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis. So today is our second number of class. And today mainly I will try to discuss this topic. So I try to discuss about that how you can easily filtering and displaying the satellite images, mainly Landsat and Sentinel, and how you can easily make the different types of band combination using those satellite images, and then how you can easily export the satellite images from the Google Earth Engine platform, and how you can easily import, filter, reduce, clip, and display the data in Google Earth Engine platform, and how to make the time series chart NDVI over a period of time, and how to export any shapefile from Google Earth Engine platform, and how to calculating any indices from satellite images. Okay, so let's go. So first of all, Earth Engine public data catalog. So mainly from this public data catalog, we can easily get all of those remotely sensed data, such as Landsat, Sentinel, MODIS, the different types of DEM data, land cover data, atmospheric data, all of the data set we can easily get from the Earth Engine public data catalog. And we can easily get all of those from this link, Earth Engine public data catalog, or we can also access all this link from the Earth Engine code editor. From the search bar, browse, we can simply click the browse data catalog, we can easily find out this link. So in this time, I try to show you that how you can easily filter and import, then filter, then reduce, clip, and display data in Google Earth Engine platform. Okay, so let's guys simply open my code editor already. So now I simply open the Earth Engine public data catalog. Simply click on here, browse data catalog. So simply click on the MODIS, and here I find out all of the MODIS product. Okay, you can see the MODIS NADIR, then MODIS albedo quality daily, surface Terra surface reflectance data daily, Terra sono cover daily, Terra land surface temperature, Terra surface reflectance. So we can get the all of the MODIS product in here. Okay, and all of the product is the same when you want to work. In this time I will show the process. You also try to follow the same process for all of those data set. Okay, so in this time I try to show you that data set for the Terra vegetation indices 60-day global 250-day resolution from MODIS. This data set I want to use, and then try to make the NDVI map, normalized difference vegetation index map. Okay, but you also try to for your own self for calculating the other data set, same process. Okay, so let's go. I simply click on here. Now I can get all of the information about this data set. We can get the data set availability time period. From this time period, we can get the data set year of 2002 18 from 2023 0202. Okay, in this time period we can get the data set, and this data set provider is that. Okay, and this is the Earth Engine snippet. Okay, so basically all of those image collection has a unique ID. Okay, suppose in this time this unique ID is that for this image collection we get the image unique ID. This is the unique ID of this image collection. Okay, and we can also get the all of the description about this data set. and also get the band. So mainly this dataset has a two band, NDVI and EVI. As well as we can also get the all of those term of use of this dataset citation. Okay, so in this term, this is my dataset. This dataset I need to import in my code editor. So this is my code editor. Okay, so this code editor I need to import. So we can import the dataset different way, different two way we can import. If you want, you can simply copy the Earth Engine snippet, simply copy this ID and paste here and give a variable name. You can put any variable name. So I put the variable name, suppose modis. Okay. So now this data set is imported in my code editor. Okay. And another way is that you can simply search here. Suppose modis NDVI. So now we can get all of those data set about the modis. You can see I want to use the 60-day global 250 meter resolution. This data set I want to use. Okay. Simply click on here. So now I can get all of the information about the dataset, same information. Okay, which information I can get in here, same information I can also get in here. Okay. Okay, so same information I also get in here. So I simply copy and paste in here, or you can simply search in the top of the code editor and you can also find out the dataset. Simply click on here, then you can also get the same information. Okay. And now you can simply import. You can see import. Click on here. Now this dataset is also imported. So the same process, same task. So different way. If you want, simply copy this ID from here and paste in the code editor and give a variable name. Or simply click on here, search the dataset and find out your dataset and click to the import. Okay. So now your dataset is the imported in your code editor. So any dataset, when you want to import in your code editor, you just follow the same process. If you want, you can copy the ID and paste in here, or search the dataset and click on here and just click to the import. This dataset will be imported. Okay. So in this time, you can see when I import this dataset, it's showing the variable name is the image collection. Okay. So in this time, it's showing the image collection. Image collection, this is a default variable name. You can use any name. There is no limit. You can use any name. Suppose I put this name, Morris. Okay. Now this image collection is fully imported in my code editor. This image collection has a two band. You can see here we can find out the NDVI band and EVI band. In this time, I want to work with the NDVI. Okay. So in this time, now I need to select this NDVI band. Okay. So for that, I take a new variable. Suppose NDVI. You can use any variable name. Now you need to call the modis. I simply call the modis because this modis, this variable, stored the full image collection. From this full image collection, I need to select only for the band of NDVI. So use the select function and use there the NDVI. Okay, so this is the modis. It stored the full image collection. It will be contain the NDVI, EVI, both of band. But in this time, I will need to work only for the NDVI. So I simply call the modis. From modis, I need to select only for the NDVI band. Okay. Now I want to check how many images I want to get for the whole world in this dataset between this time period, year of 2000 from 2023. This time period, how many images is available for the dataset? I want to check it. So I simply call the NDVI and paste in here and use the size function and just run. So now it's computing how many images are available. We can find out total 522 images. Okay, in this time period, total 2000 to 2023. But in this time, I don't need for the whole time period. I need only for the year of 2000. I need only for the year of 2000, suppose 2015 to 2020 or any specific time period. I need this data set. Okay, so in this time, I don't need for the whole world. So I need to filter this specific time period. Okay, so for that, I can simply take a variable and put the variable name, suppose filter date. Okay, you can use any variable name. You can see this 522 image is stored in a variable. What's the variable name? Variable name is that NDVI. Okay, simply copy the NDVI and paste here. Okay, now from 522 images, from these images I want to read only for those images which images are available, suppose year of 2015 or 2020 or any specific time period. Okay, just simply use a function filter date function. Mainly filter date is a function, it's filter your specific time period. You can see what is the argument, start date and end date. Suppose I need this data for year of 2015, suppose 1st January from year of 2015, suppose December 31. So in this time, I want to check how many images are available between this time period, year of 2015. So just simply use at the print and call the filter date, simply copy and paste here and use at the size function and click to the run. So now we can get how many images are available. We can get 23 images are available. Okay, so now these 23 images, if you want to check the time period, acquisition time period, so just simply copy the filter date variable and paste here and click to the run. In this time, I can get all of the information about the total 23 images. Here you can see. I simply click on here, go to the feature. 0 refers to the first image. So this is the first image. You can see what is the time. 1st January, 17th January, 2nd February, 18th February. We can get the time interval. Time interval is that 16 day. Okay, so that's why this dataset called, you can see what is the name of the dataset, 16 day. Okay, so because this dataset time interval is that 16 day. Okay, so now I need to reduce this image collection. This 23 images I need to reduce. So there's a lot of way for reduce this image collection. In this time, I want to calculate from 23 images, calculated the average pixel value of NDVI, average NDVI. Okay, so for that, I simply take a variable, suppose average NDVI. You can use any variable name. Now I call the filter date, this variable, because this variable is stored 23. And now I want to use these 23 images and calculated the average. So I simply call the filter date and paste here and use the function reduce function. So reduce is an statistical function. So when you want to calculate the different types of statistical parts, suppose average, maximum, minimum, standard deviation, then we can use here the reduce. So in this time I want to calculate the average. Okay, so just I simply use here the reduce. Then how I can reduce? I want to reduce according to average result. So just use here the mean. Okay, so now I want to just get the result. You can see average NDVI. I want to show display the result. I simply use here the map.add layer and call the average NDVI and display the result of the average NDVI. In this time I can get the result for the whole world NDVI map year of 2015. In this time you can see we can get the map look like this, ash color, because I did not use any visualization. So after the object name, we always put here the visualization. Previous class we also talk about that. So in this time, you can see they already provide the some demo code for the visualization. I just simply copy for the color code from here. Simply copy. And paste here. So this is the visualization code. Basically in this code, they are make a dictionary, curly bracket, use for dictionary, and put here the mean pixel level of NDVI start from the 0 and max up to 8000, and they also put their color plated. Okay, I simply copy this variable name and paste after the object name. So our object is that average NDVI. After that, we need to put here the visualization parameter. Okay, then click to the run. So now this color is added with our code, and we can get this visualization map. And for the whole world NDVI map year of 2015, we can get. And from this map, we can easily identify where is the dense vegetation, where is the low vegetation. We can easily find out for the whole world. Okay, so now guys, we can get this map look like this. So in this time, suppose I don't need for the whole world. I need only for my own specific boundary. Okay, so for that, we can easily import our shapefile And previous class we also try to discuss about that how you can easily import the shapefile from the asset tab. Okay, so in this time I just simply use here the dataset from USDOS dataset. And previous class we also try to discuss about this dataset and how you can easily filtering the specific country boundary. We also talk about that. So just I simply import and filter the specific country boundary. Okay, so take a variable, suppose ROI. In this ROI variable I store my specific country boundary shapefile. So filter this table. Suppose country name, I select the country, suppose Bangladesh. Okay, so now what happened? Bangladesh country boundary shapefile is stored in this variable ROI. Okay, just I clip with this ROI. So for that, I can simply use here clip function, clip with ROI. Okay, and click to the run. In this time, I can get the result only for the country boundary of Bangladesh. So it loaded, you can see loaded. But I also want to focus the center of the shapefile. So for that, we can simply use here the map.center_object function. Such as I write the code, suppose map.center_object function. And our object is that ROI. And set the value, suppose 9. Zoom level. I put the zoom level 9 and click the run. So now it automatically center focusing. And display the result of the NDVI for the whole country boundary. Time is the year of 2015. Okay, so we can get this NDVI map from the Modis for the whole country boundary of Bangladesh. Not only for the Bangladesh, any country boundary. Suppose I want to put here this, suppose Saudi Arabia. Then I can get this result of the NDVI map for Saudi Arabia. Working. So we can get the NDVI map, very less vegetation, some vegetation in here. Okay, so this is the map NDVI map of Saudi Arabia. So any country boundary, because this dataset is stored all of the country boundary. Just you can simply put this country name, suppose Ghana, and click to the run. So now we can get this NDVI map of Ghana. Okay, so now we can get this map Ghana. In this time, this map has a problem. This problem is that when I want to check the value from the inspector tab and click on this any portion of this map, suppose click on here I can get the value. You can see 501 minus 501. Click on here 6,199. So in this time, this dataset is not reprojected. Okay, this dataset is not reprojected. Mainly NDVI value, this range will be -1 to +1. Okay, this is the range of the NDVI index, -1 to +1. But in this time, we get the value 6,191. This type of value we can get. In this time, we need to reproject it, the scale value. Then we can get the result within our range, -1 to +1. Okay, so for that, for the reprojected scale value, we can find out the scale. What is the value of the scale? You can see for the NDVI. So they already mentioned the scale in here. You can see scale is that 0.001. So this is the scale value of NDVI. Yeah, so this is the scale value of NDVI. Okay, they already provide this scale 0.001. So in this time, when I multiply with this scale value with my all of those images which I want to get in here, then this result will be reprojected. And then we can get the result according to the NDVI index range, -1 to +1. Okay, so now let's go how we can easily reproject our scale value. Okay, for that, we need to reproject. You can see how many images create this map. Mainly this, how many images we can get? 23 images. Okay, These 23 images, median average pixel value create this NDVI map for year of 2015. In this time, this 23 images, I need to reproject that scale value. I just simply multiply with the value. This value 0.001. This value simply multiply with the total 23 images. Then it will be reprojected the scale value, and I can get the result -1 to +1. Okay, so let's go. How can I do that? So for that, I need to make a function. So I simply take a variable, suppose scaled NDVI, okay, and create a function and put the element name, suppose image, and put the curly bracket. In this curly bracket, I can simply put my argument. In this time, my argument is that I need to multiply this image with this scale value 0.0001. Okay, so for that, I can simply use the return function, return this image, multiply with scale factor 0.0001. In this time, you can see how many elements I use in here. I use only for the one element. One element means one image. But rest of the 22 images, what happened? So in this time, I need to copy the properties from after multiplication. I need to copy these properties and apply all of those images, which images are available between this time period. Mainly between this time period is available 23 images. Okay. So after multiply, I need to copy these properties. So just I simply use the copy properties function of this image. And I also mentioned that I need to copy these properties and apply between this time period. Okay, between this time period, all of the images I apply. Okay, so for that, I simply use the function system time start. So this is the system time start. Okay, and also mention that system time end. Okay, so I again explain what happened in here. You can see I simply take a variable name scale NDVI. We can use any variable name. Then create a function. So this is the function keyword, and put the element name image. In this time, I take only for the one element. One element means that one image. Okay, this image I multiply with this value, but I have also rest of the 22 images. Okay, so for that, I can simply copy these properties after multiply and apply these properties all of those images which are available system time start and system time end. Mainly this time period, start time and end time. So in this time period, we can get 23 images. When I want to copy these properties and apply system time start and system time end, all of those images is multiplied with this value 0.001 and reproject it. And in this time, you can see this is a function. Okay, this function, and this is my collection, filter date, total 23 images. There is no connection. In this time, this is the function, and this is my image collection, 23 image collection. In this time, I need to make a connection. So for that, I simply copy the variable name filter date and paste here, and use the function map function, and use the parenthesis and also close this parenthesis. So now it's connecting. Now, if you want to check how many images I want to get in here, you can see after multiplication with this scale factor, how many images I want to get. We can get the same number of images. We can get the 23 images. Okay, but in this time, this 23 images is the reprojected their scale value. Okay, so further I use this image and make the average. So just I simply copy the scale NDVI and paste here. Okay, now it calculating the average pixel value from the total 23 reprojected scale and also get the result. I click to the run. In this time, you can see what happened. In this time, I can get the totally white color image, because in this time, this range, you can see this range showing the mean from 0 and max up to 8000 pixel value. So in this time, I reproject it. So I simply use the -1 to +1 and click to the run. Okay, this color is also not meaningful in here. So just I simply remove all of the color. and also put my own color, suppose blue color, then white color, and finally such as green color. Okay. So now you can to check the value. Click on the Explorer tab and click on here. You can see we can get the point negative 0.04. Okay, so now we can get the result according to our range, -1 to +1, and this is the NDVI index. Follow the NDVI index range. You can see for the tens value you can get the high NDVI value, high positive value. Okay, 0.6. For the water body, we can get the negative pixel value. Okay, and it also we can get the result according our range. You see 0.7. Okay, for the tens vegetation. Okay, so now you have any question, you can ask me. Any question in here for this NDVI map?
How we can export this NDVI
Yeah.
into a separate
Okay.
raster file?
Okay, so this is our next topic
Sir,
for the exporting. Yeah, please.
if you want to do it for seasonal ones for a 1 year, we want to do it for the different seasons. So, what is the thing?
Okay, then you can simply put here this, suppose which time period you want to need. Okay, which season it need, just simply put this time in here.
Only 1 year, but different seasons.
So rainy season, wet season, summer season, this type. Yeah.
Yeah, sir. Yeah, for 1 year,
Yeah.
we want to differentiate the how much is in the rainy season, how much is in the summer, how much is in the winter, like that.
Okay. So for that, we also need to take the time period. Like suppose I want to need this in this time. Suppose wet season or summer season, I want to need this time. You can simply put the time period according this. Suppose I put here the year of 2000. Suppose for the perspective of Bangladesh, I don't know what is the summer or rain in this Ghana. So you can simply put the time period. Suppose January from suppose this time period. Suppose this is the summer season. So you can simply put this time period and make this map. Suppose you want to need the another time period. Suppose then take the another, suppose filter date, and suppose this is that wait, and also call this NDVI, same code, simply copy and put here this time period. Suppose this is that, suppose I put this from 7 to 12. Okay, so these are two time period we can get. Okay, so now we can create this map. First time you can create this map according to this date, and also create this according to this date. Okay, then we can get the visualization for the different time period. Okay, in a 1 year different season, then we can get the 2 time period image. So you create this map, one map using this filter date, and another map also create using this date. Okay, so next day I also try to show you this part, how you can easily create this different season NDVI for the for a specific boundary. So I also try to show you that using the Sentinel-2 satellite imagery, then you can easily get the better idea about that. But in this time, we can just simply change the time period, your specific time or a specific season, and also get the satellite MODIS data filter according to this time period. Then we can easily get this. There is no problem. Okay, any question in here?
Here you have taken an average for 1 year data.
Yeah.
So for which date these data sets are displaying?
In this time here I can get total 23 images.
Yes.
Okay, and I created the 23 images average pixel value of NDVI.
So this image will represent NDVI value for whole year?
Whole year, yeah. Whole year. Because whole year is the combination of the 23 years, 23 images.
Okay. And if we need to reclass of this output product, so how to do that in Google Earth Engine?
Okay, reclassify, you can also search my video on YouTube. You can also get it. I also try to show that. Reclassify, we can also do it easily. It's just I simply try to show you the video. Just a minute. So after creating this map, you can simply follow this video, then you can easily get the reclassify also. There is no problem.
And also,
Yeah.
like
So
one more
you
question.
can follow
If
also
we
this.
have,
Yeah.
okay. So also I have one more question. If we have field data sets, field validation data sets for any area, and we need to calibrate the classified data using the field data. So how we can do that?
Okay, you need to import this all of the point in the Google Earth Engine platform as a shape file.
Yeah, I mean,
Or
yeah, as a shapefile, we have. So suppose we have field dataset for a district. So suppose we have 300 points with having, the values, the density. This NDVI generally shows the density, maybe.
yeah.
So we have density values for a district, like say suppose for 300 points. So we will import those data sets, those points into Google Earth Engine. But
Yeah.
my question is how to calibrate this NDVI data with our field data sets.
So do you want to check the you need to make the confusion matrix and then also check the accuracy of that.
Yeah, you can say that also. But my question is how to recalibrate the data set. If we want to do accuracy assessment, or maybe
Yeah.
can wants to do the correcting of the satellite data readings, or calibrating the fraction of vegetation cover as per our field data set. So how to do that?
Okay, so basically in this time for the fractional vegetation, calibrate that the equation of the fraction, or we can easily use this equation, fractional vegetation equation. Then we can easily calibrate that.
Okay, there is model or function
Yeah,
called
yeah. Model or
fractional.
equation. As exactly this is the fractional vegetation has the equation. Then we can easily implement this equation in Google Earth Engine platform, and we can get this result
Okay.
for the fractional or this vegetation. Yeah. Okay, so we also try to cover this part when I want to talk about the land surface temperature using the Landsat 8 images. Okay, then with this topic also cover for the fractional vegetation. Okay, then we also need to create the fractional vegetation, then make the land surface temperature monitoring using the Landsat 8 satellite imagery. Then I hope it will be covered. And for the reclassify, we can just follow this video and you can easily reclassify NDVI. Okay, the same process.
Sure. Thank you.
Yeah. So now we can get the result look like this. And finally, we can easily export this map as a raster format and also use this map our different types of software such as ArcMap or QGIS for the final process map. Okay.
Hello, I have a question.
Yeah, please.
Okay. Why is it that we are getting negative value when it comes to the river side? And I expect that in a river we should get a zero value, not negative value. Why?
So we need to reclassify according to our values with your NDVI range, which range you want to net. You can just reclassify according to these values. Then we can get. Okay, so you also try to watch this video, then I hope you can easily understand about that. So from 0 to 0.2, then 0.2, we can easily discuss all of the details in here. So you also try to watch this video, then I hope you can easily identify and reclassify the NDVI or classification of the NDVI easily. And if not that, then I also try to discuss. There is no problem. But first of all, try to for this using this watch the video and try. Okay.
The code syntax is difficult for me as a beginner. For all the code.
So for other indices also, this is a same pattern, or will there be any changes?
So can we follow the same process for NDSI, NDWI? Like if we want to calculate NDSI, NDWI, should we follow the same process? All the functions and the process, scaling process should be the same.
So you are not audible.
We don't hear you.
Sir, we can't hear you.